Section 10.4 deals with two more theorems about triangles. And these two theorems deal with cases where we have overlapping triangles. The first theorem is called the Triangle Proportionality theorem. And when you first read it, your brain is probably going, well, that just sounds like gibberish to me. So let's read it and then let's try to make sense of it. So what it says is that if you have a line or a segment that's parallel to one side of a triangle. So in this drawing right here, segment TU is parallel to segment QS, which is one side of this triangle right here. And that segment intersects the other two sides. So segment TU right here intersects this side and it intersects this side. So it touches these two sides at points T and U. Then it divides the two sides proportionally. So if these two pieces are parallel, what happens is that if you make fractions out of the two pieces of each side, you do long piece over short piece. For that side, it will equal long piece over short piece for this side. So let's go ahead and write that in symbols and highlight some things and see if we can make some sense of this. So the if on this is if these two segments are parallel. So if segment TU is parallel to segment QS. We have to know they're parallel for this to be true. Then if we make a fraction out of the two pieces of this side, RT divided by TQ, that fraction should reduce to the same thing as a fraction we make from the two pieces of the other side. RU divided by US. So this is an important theorem because TQ and US aren't actually complete sides of any triangle. Before, we have been talking about this whole side right here and this whole side right here, because those are sides of a complete triangle. But this theorem tells us, well, you don't even have to look at the whole side. You can just look at the pieces of the side. Now, the reverse of this statement is also true. The reverse of a statement in geometry is called a converse. So what the converse says is, well, if the two fractions simplify to the same thing, then you know that those two segments are parallel. If the two fractions don't simplify to the same thing, then these two segments are not parallel. So let me write that down for you. So the converse says that if you have a line or a segment and it does divide the two sides of a triangle proportionally, so here, if we know that RT divided by TQ is the same as RU divided by US, so those two fractions made from the two pieces of each side simplify to the same thing, then we know that this segment TU is parallel to this segment QS. If those fractions aren't the same, if they don't simplify to the same thing, then these two segments are not parallel, meaning eventually they would cross if we extended them out long enough. Now, they're always going to be drawn so that they look parallel. You're going to have to test them to find out if they really are. Let's go ahead and do some examples. So the first ones, you are going to see the little arrows on here, which is telling you that those are parallel segments. So what you will do is you will go ahead and make fractions out of the two pieces of each side. So big piece over little piece equals big piece over little piece. Big over little. Big piece over little piece equals big piece over little piece. And then cross multiply just like you do in any other proportion. So we get 16y equals 240. Divide by 16. That gives you that y is 15. Next example. Doesn't matter which one goes on top. Here, if I do little piece over big piece, then little piece over big piece. Just be consistent. So x over 10 equals 4 over 8. So cross multiply, you get 8x equals 40, and divide by 8, you get that x is 5. Now, some of you may have realized that you could have done that problem just by kind of looking at it and thinking through it. And that's fine. You just need to find a way to communicate that to me. You might have realized that, oh, look, 4 is half of 8. I could get 4 by dividing by 2. Well, that means that I could get x by dividing 10 by 2. And that's absolutely fine if you realize that. You always need to be dealing with multiplying and dividing, though. It's never going to be adding and subtracting. It's always multiplying and dividing. You are absolutely welcome to think through a problem that way, but you need to be able to show me on your paper how you figured out the answer. I don't just want to see an answer with no idea how you got it. But you could certainly have figured it out that way instead of setting up a proportion. Now this one's a little bit different because notice that instead of giving me the two pieces over here on the left, what it has given me are the big piece and the whole side. So in order to match up on the right, what I need to have are the big piece and the whole side. So I need to think about, well, how long is the whole side? I've got the big piece is 15 and the little piece is 6. So the whole side is going to be 15 plus 6, which will give me 21. So think about which pieces you have and then set up fractions accordingly. So I could make a fraction here that looks like big piece over whole side, z over 14 equals big piece 15 over whole side 21. I could also have set this up as z over 15 equals 14 over 21. Blue over blue equals pink over pink. There are lots of different ways of setting this up. You just have to make sure that the two pieces on top match somehow and the two pieces on bottom match somehow. So here I have top over, I have big piece over whole side equals big piece over whole side, and the numbers on top, so numbers on top are both the big pieces, numbers on bottom are both the whole sides. Both of these come from the left over here, and both of these come from the right. If I had written it differently, I could have written z over 15. So both of those are the big pieces equals 14 over 21. Both of those are the big sides. And here the numbers on top both come from the left-hand side, and the numbers on bottom both come from the right-hand side. So there are different ways of setting it up. Both of these will give me the same thing when I cross multiply. I get 21z equals 14 times 15 is 210. So you get the same answer no matter which way you set it up. So just be consistent. Either way, you're going to get z equals 30. No, not 30. Where did I get 30? 10. Z equals 10. All right, let's look at the next type of problem. So the next type of problem is a little bit different. On these problems, it told me that the segments were parallel. The next type of question is going to say, are the segments parallel? So on these, it's sort of like testing whether the triangles are similar. What you're going to do is set up fractions and see if the fractions simplify to the same thing. So the fractions you are going to set up are going to be fractions made of the two pieces of each side. If those fractions simplify to the same thing, then the segments are going to be parallel. If they don't simplify to the same thing, the segments are not parallel. So in this one, I have 10 over 16. That reduces to 5/8. And 9 over 12, divide by 3, divide by 3, that gives you 3/4. Those are not the same. So that means that even though this piece and this piece look like they're going in the same direction, they are not parallel to each other. If I extended them, I can't spell parallel apparently. If I extended them far enough, eventually they would cross. So that's what you're testing, is are those segments parallel or not? So this is saying, well, if you went far enough, eventually those are going to cross. And I'm exaggerating. You'd have to go further than that. But they're always going to be drawn so that they look like they are. So let's test the next one. Make a fraction out of those two. 24 out of 32 and make a fraction out of those two. So notice I did little piece over big piece. So I've got to do the same here, little piece over big piece. So 24 over 32, those can both be divided by 8. That gives me 3/4. 21 out of 28, those can both be divided by 7. That gives me 3/4. Okay, so those are the same. That means that this segment and this segment are parallel. I could extend them as far as I wanted, and they would never, ever, ever cross. So that's how you test whether two segments are parallel. You may be given a problem where you have a diagram and you are asked to figure out which segment is missing in your statement. So we have QT over QR. QT is this short piece right here. QR is the whole side. Well, that has to match up with the same pieces on the other side. SU is the short piece, and the other part of the fraction has to be the part that matches the whole side here, because the bottom of the other fraction was the whole side on the other side. So the whole side there would be SR or RS. So you just look at, if you've got little piece over whole side, the other fraction also has to be little piece over whole side. The next part of these notes deals with midsegments. So first we need to tell you what a midsegment is. A midsegment of a triangle is a segment RN right here. And segment RN is a midsegment because it connects the midpoints of two sides of a triangle. So segment R is right in the middle of side MQ. And you can tell that R is the midpoint of that side because of these marks right here. So those two marks right there mean that those two pieces are the same length. So R is the midpoint. And these two marks over here means that those pieces are the same length. So N is the midpoint of that side. So the two sides have been cut in half by segment RN. So segment RN is called your midsegment. Now we have a theorem about midsegments, and it tells us two things. The first thing it tells us is that if you know a segment is a midsegment, the midsegment is always going to be parallel to the other side of the triangle. So these little arrows right here mean that midsegment's always parallel to that third side. And the other really, really awesome thing about a midsegment is that a midsegment is always exactly half as long as the third side. So if I know how long this side is, side QP, and I want to know how long the midsegment is, all I have to do is divide the length of this by 2, and I'll find out how long the midsegment is. If I know how long the midsegment is, and I want to know how long the side is, all I have to do is multiply by 2. So let me write this up for you. So I've written this up for you. The midsegment of a triangle is always parallel to the third side. So there's your parallel marks, and is half as long as the third side. So I've written this divided by 1/2 here to show you that you would take this side and divide by 1/2 to figure out how long the midsegment is. Our if-then statement says if R is the midpoint of this side and N is the midpoint of this side, then segment RN is parallel to segment QP, and RN equals 1/2 of QP. So let's use this to find some lengths. Now these are really easy problems. You're either going to be multiplying or dividing by 2. If you've got a long piece and you want a short piece, divide. If you've got a short piece and you want a long piece, multiply. So this first one, I know the side and I want the midsegment. You can tell it's a midsegment because you've got the congruency marks. So I want a shorter piece. All I have to do is divide by 2. 16 divided by 2 is 8. Well, on this one, again, I've got the congruency marks. You want to check to make sure it is a midsegment. Okay, well, I know the shorter piece, I want the longer piece. So if I know that, I'm going to multiply by 2. 14 times 2 is 28. Now these, you might get a little confused because there are a lot of numbers on here, but half of the numbers you can just ignore. The only reason that the 5s are on here is to tell you, hey, this side right here got cut in half. That piece is the same as that piece, which means this is a midpoint. And the only reason those 7s are on there is to tell you, hey, this side got cut in half. That piece is the same as that piece, which means that's a midpoint, which means this is a midsegment. So the only reason for the 5s and 7s is to tell you that you're dealing with a midsegment, and you can go ahead and use this theorem. So if you know how long the midsegment is and you want to know how long the side is, you know the short piece, you want the long piece, multiply by 2. 6 times 2 is 12. Now again, don't get overwhelmed by all of the pieces here. The only reason for the 23s is to say, oh, hey, look, I cut this side in half. This piece is the same as this piece. That's a midpoint. These two 18s are just telling you, oh, this piece is the same as this piece. I cut the side in half. That's a midpoint. C is a midsegment. So don't panic about how many numbers there are. All right, so I know the side, I want the midsegment. I know the longer piece, I want the shorter piece. Divide by 2. 18 divided by 2 is 9. So that's how you use the midsegment theorem. I want to show you one more type of problem that is similar to what you might see on the homework, because I always get questions on it and I know someone will ask. Let's say you have a triangle and you're told that that's a midsegment in there. And the middle part of the triangle you're told that it is x plus 4. And the other side of the triangle is 5x minus 13. And the instructions say solve for x. How would you do this? So what you want to do is you want to think about, well, what is the relationship between those two segments? So you know that the one labeled x plus 4 is the midsegment, and you should know that if you take the midsegment and you multiply it by 2, you would get that side. So we want to put that in an equation form. If we take 2 and we multiply it by x plus 4, that should equal this other side, 5x minus 13. And by the way, I have no idea if I'm going to get something nice here. I made this up off the top of my head. It probably won't come out very well. All right, so I want to go ahead and distribute the 2. So I get 2x plus 8 equals 5x minus 13. I want to get all of the x's on one side, and I usually try to get the x term to be positive. So I'm going to subtract the 2x from both sides. So that gives me 8 equals 3x minus 13. And then you want all the numbers on the other side. So add 13 to both sides. Oh, this is going to turn out. And that will give you 21 equals 3x. Divide by 3. And you get 7 equals x, or x equals 7. Now, if it asked you how long the two pieces were, you could go ahead and plug that in. 7 plus 4 gives you 11. And 5 times 7 minus 13 is 35 minus 13 is 22. So you can see that that works. The side is 2 times as long as the midsegment. 22 is 2 times 11. So that x equals 7 does make this work like a midsegment should. So you will see that type of problem on your homework. I wanted to make sure you had an example of that so that you weren't wondering how to do that.